Welcome to qnawire.
In this situation we have a car with a pendulum attached hanging over the top of it. Once it strikes a wall, the pendulum is free to move about an angle of theta. Now we are going to find the original speed of the cart based on what we know. We know the length of the pendulum is L, and we know that the angle is theta. For this situation we need to look at conservation of energy. Now before I can do that, I need to see what the height change of the pendulum is. Now if we look at our pendulum, it looks like this, and what it does is it goes here about this angle of theta. So now what we have is this height change right here. Now that height change is going to be L minus L cosine of theta based on the angles of this triangle. And simplified it would just be L1 minus cosine of theta. Now let's look at the conservation of mechanical energy. We always have kinetic energy plus potential energy is equal to kinetic energy plus potential energy, initial and final. Now fortunately for us, we don't have any potential energy at the beginning, we only have kinetic. So 1/2 of mv initial squared. And finally, we don't have any kinetic energy because it's hit a wall and stopped, but it does have a potential energy now because the pendulum has reached a maximum height. So we have an mgh. As usual, these masses are the same and therefore vanish. So we have 1/2 of vi squared equal to gh. Now we did say that the height change up here is L1 minus cosine theta. So let's substitute that in. So we end up with g L1 minus cosine theta. And finally, rearranging by multiplying by 2 and then square rooting it will give v equal to the square root of 2g L1 minus cosine of theta. So that's the velocity of the car before it hits the wall. Now there's going to be no more horizontal force of the car, or the bumper I should say, at the lowest point of the pendulum's motion. That's because all forces in a circle point towards the center of that circle. So all forces acting horizontally will be 0 when the pendulum is going to be either at the very bottom or 180 degrees from there, which would be perfectly above it, which it never reaches. So in this case, there's going to be no horizontal force at the lowest point of motion.